true and false questions to try and give you a sense of how to approach these types of questions. So for the A2, my section of the work, the consumer theory, is only going to be asked using true and false and MCQ questions. And I think sometimes it can be a little bit difficult to approach MCQs. And the way that I like to think about MCQ questions is I like to approach them with the view to identifying wrong answers. Because if you can eliminate wrong answers, you are left with right answers. The only time that you will be looking for a right answer specifically is if the question is a calculation question. And then it means you would have done the calculation, you get an answer, and then you see if your answer matches one of those that appear as A, B, C, or D. Okay, so that's what I'm hoping to do in today's revision and tomorrow's revision, is to try and bring across not only the theory, but also some of the approach of how to do true and false and MCQ questions. But before I start, I thought maybe if anyone has a particular question that they want me to do, please type it in the chat. My aim is to do mostly chapter 3 and some of chapter 4 today, and then tomorrow to do chapter 4 and chapter 5. So chapter 5 is the work that you were tested on for the A1. And for that, I'm going to use the tutorial questions to frame what I will cover. Okay, so if everyone's happy with that, I will start going through the A1, but I'm only going to go through the questions that are relevant for the theory that is likely to come up in the A2. So I'm not going to do questions 1 or 2 because this covers theory that isn't part of the A2. So we can go straight to question 3. So in question 3, it says, in the figure below, budget line B1 shows the highest relative price of shelter. True or false? So B1 is the solid line here. And if we look at B1 relative to B2 and B3, how you would describe B1 in this picture is you would say, well, it is the flattest sloped straight line. Why that is important to recognize is because the slope of the lines in this picture, as they're plotted with food on the x-axis and shelter on the y-axis, means that the slope of these lines as they are plotted represents the relative price of food. So when we plot a budget line, its slope represents the relative price of the good that is on the horizontal axis. So I would calculate the slope of these budget lines using the price of food divided by the price of shelter. So that tells me that B1, the line that I've highlighted in purple, represents the cheapest relative price of food, the lowest relative price of food. I see that the camera has frozen, but it's fine. I'm going to carry on talking. So it represents the cheapest, or if this represents the lowest relative price of food, it must then represent the highest relative price of shelter. Okay. So the way that I can reason that is if I wanted my budget lines to represent the relative price of shelter, so if I could visualize it, I would just rotate this picture. Because now shelter is on the horizontal axis. And if I put the picture this way around, what I see is that B1, the purple line, is now the steepest of the 3 lines. And so B1 represents the highest relative price of shelter, the highest relative cost of the good on the horizontal axis. So the answer to this question is true. Okay, so this is a slightly tricky question because what it is asking you to do is to apply the theory really specifically. It's asking you to understand that a budget line, the slope of a budget line represents the relative price of a good. But the way we need to interpret the slope of that line is with reference to the product that is on the x-axis. Okay, so the answer to this question is true because, okay, so whoever has your microphone on, I think it is Robert. Your microphone is unmuted. There you go. Thanks so much. So the answer is true because the flattest line in this representation tells us something about the relative price of food being relatively high and the relative price of shelter being relatively low. Okay. Does that make sense? So a slightly tricky question, but it's really trying to get at your understanding of what a relative price is and how it relates to the slope of a budget line. Everybody happy with that? You can give me a thumbs up, or if you want me to repeat it, you can just mention in the chat. Otherwise, I'm going to move on to the next question. Okay, so I see quite a few thumbs up, so I'm going to move on to the next question. So question 4 is about transitivity. So we get told that Smith likes cashews more than almonds. So I'm going to write cashews are preferred to almonds, and likes almonds more than walnuts. So almonds are preferred to walnuts, which means by transitivity, cashews are also preferred to walnuts. C, preferred to walnuts. He likes pecans equally well as macadamias, so equally well, and prefers macadamia nuts to almonds. So macadamia nuts are preferred to almonds. Assuming his preferences are transitive, he prefers pecans to walnuts. Okay, so if pecans are equivalent to macadamia and macadamia is preferred to almonds, it must be that P is preferred to almonds. Okay, we also see that almonds are preferred to W. So if almonds are preferred to W, and pecans are preferred to almonds, it must then be that pecans are preferred to walnuts. So the answer is true. Okay, so we're using transitivity here to figure out the logical ranking of these different goods for this consumer. Everybody happy with transitivity? I think the answers to this question were pretty good on average in the A1. So can I move on to question 5? Because question 5 in the A1, I think only 20% of people got this question correct. And I'm going to show you why this was quite a tricky question and how I'm kind of expecting you to really understand the theory and be able to piece all the different parts together. Okay, so I'm going to move on to question 5. So question 5 says, indifference curves are negatively sloped because of the diminishing marginal rate of substitution. True or false? Okay, so what this question, when you have a true or false question, what I'm actually asking you to engage with is, do the different parts of this statement, are they true all of the time? Is there no instance in which this statement falls apart? Okay, and this is where the trick comes in. So indifference curves are negatively sloped. So how does a negatively sloped indifference curve look? So one example of a negatively sloped indifference curve could be this. So if I have X on the Y-axis, X on the X-axis and Y on the Y-axis, this is one example of a negatively sloped indifference curve. Then I could have another type of negatively sloped indifference curve. And that could be an indifference curve that looks like this. This gives us an indifference curve where the consumer is choosing between two perfect substitutes. Okay, so this indifference curve is negatively sloped, but this indifference curve has a constant marginal rates of substitution. This indifference curve here has a diminishing marginal rates of substitution. So if we look at these two individual indifference curves, we can see that the reason for a negatively sloped indifference curve can't possibly be because of diminishing marginal rates of substitution. Because here is an example of a negatively sloped indifference curve that has constant MRS. So the fact that this type of indifference curve exists makes this statement false. The reason why indifference curves are negatively sloped is because of the axiom more is better. So because of monotonicity. The reason why monotonicity gives us negatively sloped indifference curves is because, let's say, I'm currently consuming at this point on this indifference curve. So I have so much Y and so much X. And then I want to know if I was to increase my consumption of X, how would I be able to increase my consumption of X, keeping my utility constant? The only way that I would be able to do that is by reducing my consumption of Y. So increasing X whilst maintaining your level of utility means having to sacrifice some consumption of the other good. If I could increase my consumption of X without sacrificing Y, I would move onto a higher indifference curve. So the fact that more is better is the reason why we have negatively sloped indifference curves. It isn't because of the MRS. The MRS gives us the slope of our indifference curves as the rate of change. So is our slope decreasing or is our slope constant? Or in some weird cases, is our slope increasing? So in examples where we have goods and bads being consumed together, we may actually find an increasing marginal rate of substitution. Okay, but the point stands that I can prove that there is a case in which this statement doesn't hold, and that is why the answer is false. Okay, this is probably one of the harder true and false questions because it's expecting you to really understand a lot of the theory and how it all comes together in one really, really simple statement. Okay, so when you approach true and false questions like this, which are engaging quite heavily with theory, always think about, is this true all the time? Is there any case in which this cannot be true? Okay. Then 6 says an Engel curve always slopes downward for an inferior good. This is true. The reason why an inferior good always has a downward sloping Engel curve is because when we plot an Engel curve, we plot the consumption of the product, so the amount that we consume of X, let me call it the quantity of X, against our income, M. So an inferior good we define as a good where if our income increases, we consume less of that good. So for example, if I have so much income, for argument's sake, and I choose to consume this much X, so that is one consumption choice. Let's say my income falls, how would that affect my consumption of this product if it is an inferior good? If I have less income, I respond by consuming fewer normal goods and more inferior goods. So inferior goods are goods where our income and our quantity consumed are negatively related. So if my income goes down, I would end up consuming more of this inferior good. So all of the different combinations of income and X for this product, if we connected all of them, we would get our Engel curve. And so for an inferior good, an Engel curve is always downward sloping. Okay. The other type of Engel curves we get is you could have an Engel curve for a normal good, which is always upward sloping. But then we can distinguish between necessities and luxury goods. So if this is M and this is the quantity that we consume of X, and this is a 45-degree line, what we would say is that if you are consuming a normal good, which is a luxury, what that means is that if your income were to double, the response of your consumption to that doubling of your income would probably be more than double. So a luxury is something that you hold out for. You only buy it once you have the income to do so. That is very different to a necessity, where a necessity is something that if your income was to double, it's not like your consumption of that thing would double. Like toilet paper. Just because you have twice as much income doesn't mean you're going to double, even more than double the amount of toilet paper you consume. There's kind of a limited set amount, necessity type amount of toilet paper that you're going to be consuming every week, month, whatever. So what we would then say is that an Engel curve for a luxury good is going to have a relatively flat slope, okay? Because what it means is that if our income increases a bit, we're going to respond by consuming quite a lot more of this good. Whereas a necessity would have quite a steep positive slope. Because if our income had to increase a lot, proportionately, our consumption isn't going to increase by much. So these are two examples of normal goods. They have positively sloped Engel curves, but the slope of these Engel curves tell us something about whether they are necessities or luxuries. Okay, so I've just thrown in some extra theory there. Everyone happy with the true and false questions up until now? Is there anything else that you would want me to explain? You can just put it into the chat. Otherwise, I'm going to move on to the multiple choice questions, just so that I can show you how I would go about navigating MCQs. So I'll just give you a little bit of time if you want to type something in the chat. Otherwise, I'll move on to question 10 in the MCQs. The question 7, 8, and 9 isn't work that will be covered in the A2. Okay, so I'm going to move on. Okay, so this is question 10. And this question deals specifically with a kinked budget line. So what we have here is a consumer who is consuming X and Y. And this is their current budget constraint. What we need to do in this question is we need to identify what is the shape of this budget constraint telling us about the prices that this consumer faces. The important thing to remember here is that the slope of this budget constraint, as it is plotted here, represents the relative price of X. So it is the price of X over the price of Y. important information because what it tells me is that if I was to hold the price of Y constant, in other words, if I was to say this number here stays the same, irrespective of how much Y and X is consumed, that tells me that the only reason the slope of this budget constraint is changing is because the price of X is changing. So the slope of the budget line up until this amount of X is flatter than the budget line once you consume beyond X1. So holding the price of Y constant, the reason why the budget constraint changes slope is because beyond this consumption of X, the price of X must be increasing. Okay, so the budget constraint could look this way because for larger quantities of X, the price of X increases. Okay, so that is one reason. The other reason for why this budget constraint could look this way is because what if we assume the price of X remains constant? So if we had to assume that the price of X stays the same, no matter how much Y or X this person consumes, the reason why the budget constraint changes from being quite flat to very steep must be because for smaller quantities of Y, okay, just make sure your microphone is turned off. I can hear somebody's microphone is on. So the other reason why it could look this way is because for smaller quantities of Y, the price of Y decreases. So the reason I'm pointing this out is because, again, to illustrate to you that the slope of a budget line depends on both the prices of X and the prices of Y. It isn't necessarily the case that the slope of a budget constraint changes only because one of the price changes. It can come from either product because the slope of the budget constraint is made up of both prices. Okay, so the only reason the budget constraint could look like this, assuming we hold one of the prices constant, is because either the more we consume of X, X gets more expensive, or the less we consume of Y, Y becomes cheaper. Okay, so we look at the answers. A says there is a price reduction of X for large quantities. If that was true, if for large quantities of X, X became cheaper, this line wouldn't get steeper. That line would get flatter because the slope of this line is Px over Py. And so Px getting smaller would make the slope smaller. And so it would make this budget line flatter at high values of X. So A can't possibly be right. B, a price increase of X for large quantities. Yes, that is one of the reasons why the budget constraint could look this way. C, a constant price of X for all quantities purchased. If that was the case, then it may be that the budget constraint could look this way, but only if we know what is happening to the price of Y. So C can't be necessarily correct because we don't know anything about how the price of Y is changing. Okay, so if all we know that the price of X is remaining constant, if that's it, that's not enough information for me to figure out whether or not that's the reason why the budget constraint looks this way. So C is incorrect. D, price change of X and a nominal income increase for the consumer. That can't be correct because if there is a price change of X and an income increase at the same time, this budget constraint would also have shifted either leftwards or inwards, depending on whether or not the price change of X dominates that income effect. So for example, if the price of X was going up at the same time as income is going up, that could actually mean that we end up being relatively poorer, depending on how large that price increase is. We just don't have the right kind of information for this to be the right answer. And so the only answer here that could plausibly give us this shape budget constraints is B, that there's a price increase of X for large quantities. Everybody happy with that answer? Before I move on to the next, you can just give a thumbs up. I'll judge from how many thumbs up there are if everyone is happy with that, and then I can move on to the next question. Okay, great. Okay, question 11. I think one of the class reps did mention to me that this is something that students were talking about on the WhatsApp group. So it's a good thing that I'm covering this type of question. So the question says, Hilton spends all his 500 Rand weekly income on two goods, F and C. His utility function, just going to see if I can improve the focus. Okay, his utility function is given by the utility of F and C equals 2F plus 3C. The prices of F and C are price of F is 10 Rand and price of C is 20 Rand. Which one of the following statements is incorrect? Okay, so here we're looking for the incorrect answer as the answer to this question. Okay, so you have to be very careful with these types of questions. So we have all this information, and now we're going to judge each of these answers using the information here. So A says Hilton consumes 50F at his best affordable point. Okay, so how do we figure out Hilton's best affordable point in this particular example? So the best affordable point for this consumer, we're going to find as the point where the marginal utility of F divided by the marginal utility of C must be equal to the price of F over the price of C. So this is the condition for finding an optimal consumption point, but it must happen together with being on your budget constraints. So these are the two conditions that need to be fulfilled in order for a consumer to be optimizing. And these are the two conditions that come out of the Lagrangian first order conditions. So this is how we actually figure out that these are what needs to be fulfilled. Okay, so we need to find the marginal utility of F, and we need to find the marginal utility of C. We get given PF and we get given PC. Those are 20 and 10. Okay, so the marginal utility of F, we find by taking the partial derivative of the utility function with respect to F. So we take the partial derivative of this function 2F plus 3C, which means we hold C constant. So when you take a partial derivative of a multivariate function like this, you treat the other variable as a constant. So if I take the first derivative of 2F plus 3C with respect to 3C with respect to F, I get 2. Okay, so the first derivative of 2F with respect to F is 2, and the first derivative of 3C with respect to F is 0, because 3C is just a constant. The marginal utility of C, I'm going to work out in the same way. I'm now taking the first derivative or the partial derivative with respect to C. So taking the partial derivative of 2f plus 3c with respect to c gives me 3. Okay, so the first derivative of 2f with respect to c is 0 because f is a constant. And the first derivative of 3c with respect to c is simply 3. So what I have now is that MUF over MUC is 2 over 3. Okay. Price F over price C is equal to 10 over 20, which is a half. What does this tell us? It tells us that for this his marginal utility ratios always exceed his relative price. Okay, so in other words, the rate at which he is willing to trade off food, and actually we don't even know what F and C represents, I'll just talk about them as F and C. The rate at which he is willing to trade off F and C against each other always exceeds the rate at which he has to trade these two things off in the market. The market set those prices. He has to trade them at that rate, 1 to 2. So what does this mean for his consumption choice? Okay, so this is where Gosson's second law becomes really useful. So if this is the optimal consumption condition, I'm going to rearrange it so that I move this term here over to that side. And I'm going to move price F over to this side. So I'm just cross multiplying. So I'm rearranging this to look as follows. MUF over price of F equals MUC over price of C. Just make sure to turn off your microphone. Michelle, your microphone is on. Great, thanks. Okay, so MUF over price of F should be equal to MUC over price of C when we are optimizing our consumption choice. And that is the same as that. Okay, this is just Gosson's second law representation. If I now look at what I have here, which is MUF over MUC equals 2/3, is greater than PF over PC, which is a half, what I can then say is that 2 over 3, and that's 1 over 2. So let's say that's 10 and 20. Let's keep it in that form. So this is my MUF, 2, and my MUC is 3. My price of F is 10, and my price of F is 20. If I rearrange that formula to be MUF over price F, I would have 2 over 10. So this is MUF over price F. And the other side is going to be 3 over 20. And that's the MUC over the price of C. This would be the same as 1/5. And 3 over 20, I can only keep it as 3 over 20. So let me put it in common values. So 2 over 10 would be 4 over 20. So for this consumer, their marginal utility of F from every rand they spend on this good F always exceeds the marginal utility they get from C from every rand they spent on C. In other words, if this consumer had a rand to spend, they would always spend it on F because that would always give them more benefit, more utility than spending it on C. So how should this consumer be consuming in order to be rational? If they get more utility from consuming F, whatever they spend on F from C, it means they should spend all of their money, all of their income on F. So Hilton has 500 Rand to spend each week. F costs 10 Rand, which means he would buy 500 divided by 10 is 50 F. Okay, so this is a whole lot of theory going into proving that A is absolutely true. Hilton does consume 50 F at his best affordable points because Hilton's optimal decision, rational decision here, is to only buy F. So because A is correct, because A is true, it isn't the right answer for this question because we're looking for the incorrect answer here. Okay. B then says, Hilton would derive positive utility even if he chooses to consume no F. So what do we have to do? We have to consider a situation in which Hilton consumes no F, but then must be consuming some positive C because Hilton needs to consume something in order to get utility. He has money to spend, he's going to spend it to get utility. If we look at this utility function here, what we see is that if F is 0, if he consumes absolutely no F, but he will consume some positive amount of C, it means that he can get positive utility. Okay, so let's kind of play it out that he spends all his 500 Rand on C because he chooses to consume no F. If he spends 500 Rand on C and C costs 20 Rand per unit, that must mean he's consuming 25 units of C. How much utility would he get consuming no F, but 25 units of C? According to his utility function, he would get 2 times 0 plus 3 times 25. So his utility would be 75 utils. Okay, so B is absolutely true. Hilton would derive positive utility even if he chooses to consume no F. So this is not the correct answer for this question where we're looking for an incorrect answer. Okay, so A is eliminated, B is eliminated. C then says, at his best affordable bundle, his marginal utility from F is twice as large as his marginal utility from C. Okay, so let's go back to all the math we did. So at his best affordable points, what we figured out is that his marginal utility from F is always 2. His marginal utility from C is always 3. That does not agree with the statement of C. Okay, it is not true that his marginal utility from F is twice as large as his marginal utility from C. In fact, his marginal utility from F is smaller than his marginal utility from C. You might then think, okay, but if his marginal utility from F is smaller than his marginal utility from C, why does he optimize by only consuming F? The reason is because F is cheaper than C. This is why we have this function or this condition that combines both the marginal utilities and the prices. Remember, when a consumer is having to make a rational decision, they're having to contrast the benefit of doing something with the cost of doing something. The benefit of consuming is in the form of utility. The cost of consuming is in the form of prices that are paid. So just because something gives you less marginal utility doesn't mean that isn't going to be the product that's going to give you the greatest satisfaction, because that product could be really, really cheap. And we are looking for the cheapest satisfaction. Okay. So C is incorrect, which is why it is the correct answer to this question. Okay. And then just to check that D is in fact true, which makes it wrong for this question. The opportunity cost of F is a half C. Okay, so the opportunity cost of consuming F is represented by the relative price of F. The relative price of F is the price of F divided by the price of C. 10 Rand divided by 20 Rand gives me a half. And we always represent our opportunity cost in terms of something. It's what you're having to give up. So every time I choose to consume 1 unit of F, so I'm spending 10 Rand on that 1 unit, what am I having to give up for that? What is the trade-off? The trade-off is half a unit of C. That 10 Rand is 10 Rand that could have gone towards C. And that 10 Rand would have bought me only half a unit of C. So D is true, which is why it isn't the correct answer to this question. Okay, so I feel like I went through a lot of theory there, but I hope that was all very useful theory to help you with your preparation for the A2. Everyone happy with question 11? Everything that I went through. I think I am still going to go through a few more of these concepts. Okay, everyone good? Those of you who would like to give a thumbs up, it just helps me to gauge where everybody's at before I move on to the next question. Okay, great. Okay, question 12. If a consumer of food and shelter is willing to give up 3 units of food in exchange for 1 unit of shelter, and food is priced at 100 Rand and shelter at 200 Rand, then the consumer is purchasing, question mark. We're going to use exactly the same theory here as we used in question 11. So what is the statement? A consumer is willing to give up 3 units of food in exchange for 1 unit of shelter. That tells me that the marginal rates of substitution of food for shelter is 3. Okay. So visually, how that would look is if we have shelter on the x-axis and food on the y-axis, it means that currently where I am, I would be willing to give up 3 units of food in order to just get 1 more unit of shelter. Okay, so that's me making that decision to substitute food for shelter at a rate of 3 to 1. How do we calculate the MRS? We calculate the marginal rate of substitution by taking the marginal utility of the product that is on the x-axis divided by the utility of the product on the okay. So what this is telling me is that the reason why I am willing to give up 3 units of food for 1 extra unit of shelter is because what I currently get in the form of marginal utility from shelter is 3 times what I get from marginal utility when I consume 1 extra unit of food. So the value that shelter gets, or the value I get from shelter, far exceeds what I get from food, 3 to 1. Okay, so the MUS over the MUF is 3. These 2 prices here tell me about the relative cost, the rate at which I have to trade these 2 goods. Okay, so using this picture here, what that means is that my price of S over my price of F is going to be 200 over 100. So it's going to be 2. Okay, so I'm willing to give up 3 food for 1 shelter. The market is telling me I only have to give up 2 food for 1 shelter. So let's think through this logic. If you're somebody who is consuming these 2 goods, you are willing to give up 3 units of food for 1 shelter. But in the marketplace, you only have to give up 2 units of food for 1 unit of shelter. What does that mean about your consumption? It means you're going to take that deal. If you are that more willing to give up food for shelter, it must mean that you should be consuming more shelter. The thing that actually gives you relatively more value, more benefits than what it costs you. Okay, so this information tells me that this consumer is currently under consuming food, shelter, sorry. So this consumer is not consuming enough shelter to be optimizing. A is wrong because A says they're consuming just the right amount of each good for utility maximization. A can't possibly be right because what we see is that currently the ratio of marginal utilities isn't equal to the ratio of prices. These two things need to be equal in order to be optimizing, in order to be achieving the maximum utility possible given the income and the prices you face. So A is incorrect. B says too much shelter. That is incorrect because what we know about this consumer is they are very willing to give up shelter. To give up food for shelter. Oof, it's a lot to hold all of this in your head. So they're very willing to give up food for shelter, more willing than what the market expects them to trade food for shelter. So B is incorrect. C says too much food for utility maximization. That is correct. They are currently consuming too much of the thing that actually gives them less relative benefit for the cost. And then D says less than the budget would allow. We can't know that. Okay. So D can't be correct unless we know something about the exact combination of food and shelter that they are consuming. It is totally fine for a consumer to be consuming where the MUS over the MUF is greater than the price of S over the price of F. That is totally fine. They just wouldn't be optimizing. So if S is on the x-axis and food is on the y-axis, and this is their budget constraint like this, they could be consuming at a point where this MU ratio exceeds the price ratio if they're somewhere like that. So this point here tells me they're consuming with all their income because they're on the budget constraints, but they aren't optimizing because at this point here, their marginal utility ratio, so the MRS, is steeper, is greater than the price ratio, the budget line. So this exactly describes the problem that we're working with here. This person is consuming too much food and too little shelter. They would optimize by rearranging their consumption so that they would end up at a point of tangency between their indifference curve and their budget constraints. So this consumer would do better by reducing their consumption of F and increasing their consumption of S. So the picture should update soon, and then you can see exactly what I drew. Sorry, the camera always gets a bit slow when I'm streaming to so many people. So hopefully it does update quite soon. Otherwise it will stay frozen forever. No, there we go. Okay, so currently the MRS exceeds the relative price. That tells us that the consumer is consuming too much food in order to optimize. And so they would be better off reallocating their budget towards consuming less food and consuming more shelter. And that would take them to a point of tangency between a highest attainable indifference curve and their budget constraint, which would then satisfy the condition that their marginal utilities, the ratio of their marginal utilities is equal to the ratio of the prices. Okay, so the answer to question 11 is D. They're consuming too much food for utility maximization. Okay, everyone happy with that? Because I think what I'm going to do next is I'm going to move on to a Hicksian decomposition. So I'm going to do the long question 4 in the A1. And then I'm going to come back and I'm going to do question 14 from the MCQs, because I think we first need to go through the way that the substitution and income effects works before I come back to talk about this particular multiple choice question. Okay, so I'm going to skip forward to question 4, and then I'll come back and do question 3. Okay, and then I'm going to leave the rest for tomorrow's revision, where I cover the rest of chapter 4 and chapter 5. Okay, so question 4 said, consider a consumer of 2 goods. Okay, I see a question in the chat. Where can we find these answers? Is this the A1? Yes. So I'm just going through the A1 because it just helps to have questions that I can talk about the theory around. Because I think at the end of the day, you need to see how the theory works in practice. I don't want to just teach you the theory without showing you application of it. Okay, so there's a consumer of 2 goods, X and Y. The consumer has a weekly income of 1,200 Rand to spend on both goods, and the prices of X and Y are 60 Rand for X and 80 Rand for Y. The consumer has well-defined preferences that can be represented by smooth, downward sloping, and convex indifference curves. For this consumer, both X and Y are normal goods. Okay, so I've given you a whole lot of information, which we're now going to use to plot this consumer's consumption decision. So 4.1 says, determine the equation of the consumer's budget constraints. So for 4.1, I was actually open to 2 answers. So you could either give the budget constraint in the form income is equal to the amount spent on X plus the amount spent on Y, or you could have given me the form of the budget constraint that we end up plotting, where we have the Y product on the Y-axis and the X product on the X-axis. So the 2 answers I would have accepted for 4.1 is 1,200, the income, is equal to 60 times X plus 80 times Y. So that's one way we could represent it. So this basically implies total income must be equal to total expenditure. The other representation would have been Y is equal to the real income of Y, so 1,200 divided by 80, plus 60 over 80x. Okay, now you could have simplified that, but essentially I would be happy with that. Now we have to look at my hand frozen for the next 30 seconds. Oh, great. That was not painful enough. So 2 representations would have been fine for me. Okay. 4.2, draw a graph depicting the consumer's budget constraints and their best affordable bundle, X1, Y1. Label the budget constraint B1 and the best affordable point A. Be sure to label your axis intercepts. Your graph does not need to be to scale. Is product X on the X-axis, product Y on the Y-axis. The budget constraint would have intercepts equivalent to the real income of this consumer in terms of the 2 goods. So the real income in terms of y is this intercept here, 1,200 divided by 80, which is 15, if I'm not mistaken. So that's 15. Yes, 15. And then x would have been 1,200 divided by 60. So if I spent all 1,200 Rand on x, I would be able to buy 20 units. So the budget constraint would be a straight line connecting those two intercepts. And then the best affordable point, you just have to essentially show that you understand that it is going to be a point of tangency between some highest attainable indifference curve and this budget constraint that you've just drawn. So you could just represent it as follows. So this is x1, and this is y1, and this is point A. So I'm just giving a representation of the optimal consumption points using this point of tangency. Okay, then the next part of the question says the price of X falls to 40 Rand. Okay, now in the test, I told you not to redraw this because it would just be unnecessary to redraw it. So you can just do the rest of the question on the same figure. So if the only thing that happens is that the price of X falls to 40 Rand, now you need to add the new budget constraint on your graph and label it B2. So if the only thing that is changing is the price of X, it means the y-intercept doesn't change because the y-intercept is made up of income and the price of Y. Those two things aren't changing. So 15 remains 15. The x-intercept will change. So the x-intercept is income divided by the price of X. Price of X is now 40. 1,200 Rand divided by 40 means my new maximum consumption of X will be 30. 1,200 divided by 40. So my new budget constraint is going to connect the intercept of 15 with the intercept of 30, and that is my new budget constraint, B2. So the effect of the price of X decreasing is that our budget constraint swivels outwards along the x-axis. So this consumer has seen an increase in their purchasing power. The way that we can visualize that purchasing power is in terms of the feasible set. All of the options, all of the consumption bundles available to this consumer. So after the decrease in the price of X, we now have all of these additional consumption bundles, all of that space, that area in between B2 and B1. Those represent new consumption options or possibilities for this consumer. Okay. 4.4 then says, using the Hicksian decomposition, show the substitution and income effects of this price change on the consumer's consumption of X. Label the bundle X2Y2 that represents the Hicksian substitution C, and the consumer's new best affordable bundle X3Y3 as bundle D. Okay, so we're having to show two different bundles, C, which shows us the substitution effect, and D, which shows us then the additional income effect. So the movement from A to D will be the entire price effect. Okay, so how do we find the Hicksian substitution effect in this picture? Okay, so, oh geez, I see the chat now. Thank you, Ms. Shaw. That indeed should be a negative because it is a negatively sloped budget constraint. Okay, thank you so much for pointing that out. Okay, so yes, you're absolutely right. The budget constraint should be y is equal to the intercept minus the relative price of X times the quantity of X. I need to keep a closer eye on the chat so that I don't run away with wrong answers. Okay, so how do we find the Hicksian substitution effect? So the substitution effect is reasoned as follows. It tells us if this consumer could remain equally satisfied as before. In other words, if this consumer could stay on their original indifference curve, how would they substitute between these two goods in order to bring their marginal rate of substitution, the rate at which they are willing to trade these two goods, in line with the rate at which the market wants them to trade these two goods, which has changed now because the price of X has changed. So how we think about it as follows. The new price ratio that the consumer faces is given by the slope of the new budget constraints. So the slope of B2 tells me how must this consumer trade the two goods according to the market prices of 40 Rand and 60 Rand. Or is it 40 Rand and 80 Rand? Okay. But we want this consumer to stay as satisfied as they were before. So what we want to find is at which point would their MRS, so the slope of their indifference curve, assuming they stay on their old indifference curve, be equal to this new relative price. So we draw this hypothetical budget constraint, and we find the point of tangency between this hypothetical budget constraint that represents the new relative prices and our original indifference curve. So this point here, point C, represents the points at which the consumer matches their rates of substitution, the rate at which they're willing to substitute these two goods, with the new rate at which they have to substitute the two goods. So the movement from A to C represents the substitution effect. So the substitution effect here is increase the amount of X you consume, but decrease the amount of Y you consume. So this substitution effect makes sense because if the price of X goes down, it makes whatever utility or whatever benefit I can get out of X relatively more attractive than it was before, right? So you can now get cheaper marginal utility from X. And so the rational consumer would move their consumption away from Y, which now has a higher marginal utility per rand, a lower marginal utility per rand, because the price of X has gone down, which means the marginal utility per rand of X is now less. So this consumer would be reasonable to substitute their consumption away from Y towards X. And that's what the substitution effect reveals. Okay, so when the price of X goes down, the substitution effect will be to consume more X, but consume less Y. Okay, so the consumer makes this first initial substitution, trying to stay equally as satisfied as before, but now having to reason according to these new relative prices of X and Y. At C, what we should then notice is that C falls underneath the new budget constraints. In other words, trying to achieve the same amount of utility as before by substituting between these two goods doesn't end up maximizing your utility. You are now consuming within your budget constraints. In actual fact, you could be happier or more satisfied than you were in the past because you have all of this additional purchasing power. So the consumer would then realize that it is possible, through now facing higher real purchasing power, to be happier than they were. So they would move from C on their original indifference curve up to a higher attainable indifference curve that is now tangent to their new budget constraints. The question now is, where would this new point of tangency with a higher indifference curve and the new budget constraint be? And this is where the information about these two goods being normal goods becomes important. So X is a normal good and Y is a normal good. This is important information to acknowledge because it tells us how this consumer will respond to having greater purchasing power. If this consumer is now really or relatively, in real terms, wealthier than they were before, they have all these additional consumption possibilities available to them, it means that they would choose to consume more normal goods and consume fewer inferior goods. So the income effect illustrates that decision. The income effect tells us, how does this consumer's consumption change facing higher real purchasing power? So normal goods would mean wherever you end up has to be positive income effects for both of these goods because both of them are normal. In other words, I theoretically cannot end up here. Because if I ended up at a point like this, it means that my income effect for C is negative, which completely contradicts the nature of X, which is it's a normal good. So the income effect, which is the movement from C, where our substitution effect ended, onto our now higher indifference curve and higher budget constraints, that needs to be positive. So we have to end up somewhere to the right of C for X to represent a positive income effect. So the movement from C to D is the income effect, and it's positive for X. It goes from X2 to X3. And it is also positive for Y because we end up going from Y2 to Y3. So the final outcome of D is theoretically correct. It shows that these two products are normal goods. Okay. And then to complete the picture, you would have to have an indifference curve tangent to the new budget constraints at that point, D. Okay, so these are all the things you have to think about when you are drawing the substitution and income effects. The important thing to remember, to get the substitution effect, you're thinking about holding utility constant, but now trying to find where does the consumer's MRS now equal the new relative price of these two goods. The income effect tells us once we've tried to hold our utility constant, is it now possible to be even more satisfied if we actually had an increase in our purchasing power? Or if prices had increased, we would have now had less purchasing power, which means we wouldn't be as satisfied as we were in the past. So the direction of the price change is then going to tell us whether or not we jump up to a higher indifference curve for the income effect or whether we move down to a lower indifference curve for the income effect. Okay, so this is the substitution and income effect when the price of one product is decreasing and both goods are normal. The last part of the question 4.5 then asked, what is the consumer's marginal rate of substitution at bundle D? So bundle D is the new optimal consumption point, which means it must satisfy the condition that the marginal rate of substitution of this consumer is equal to the new relative price of X. Okay, so the budget constraint, the slope of that budget constraint must be equivalent to the MRS. So the slope of the budget constraint B2 is going to be the price of X over the price of Y. The price of X is now 40. The price of Y is still 80. And so 40 divided by 80 gives me a half. But a half isn't the full answer, because remember, the margin rate of substitution, just like the opportunity cost, the relative price, has to be represented in terms of something. It's the trade-off. It's what you're having to give up. So MRS tells us, yes, you're willing to give up half, but half of what? You're willing to give up half a unit of Y for 1 more unit of X. So the answer to 4.5 would have been half Y, okay, in order for it to be complete. Alternatively, you can kind of think about the reciprocal of that. If the MRS at point D is half a unit of Y for 1 unit of X, that is equivalent to 2 units of X for 1 unit of Y. So the reciprocal can also be used in that case. Adrian asked in the chat, how do you know where to put D exactly on the B2 budget curve? You won't know exactly where to put it. Okay, so you won't know exactly because I haven't told you what Y3 and X3 are in actual quantities. All you need to make sure is that D satisfies the condition that both goods are normal. Okay, so D has to be somewhere on B2 so that the income effect for X is positive and the income effect for Y is positive. So if I had put D all the way down far to the right on B2, that would have given me a positive income effect for X, fine. But it would have given me a negative income effect for Y, which would actually tell me that Y is inferior. So it doesn't need to be at an exact point, but it has to be at a point that holds up with the logic of these two goods are normal goods. That is the main thing. Okay. Okay, so the last question I'm going to do today, and then I'm going to leave the rest for tomorrow, because I really wanted to spend quite a lot on this optimization, is question 14. So question 14 is dealing with the income and substitution effect, but now in a multiple choice question, which can actually be a little bit tricky unless you write down certain information that guides you to the correct answer. So that's what I'm going to show you now, is how do you write down all of the things that would help you to figure out the substitution and income effect and the directions of them in a multiple choice question. So the question says a consumer buys bread and steak. Suppose that for this consumer, bread is an inferior good. So that's important information. And steak is a normal good, important information. Suppose the price of steak rises, important information, while income preferences and the price of bread remain unchanged. So the only thing that's changing is the price of steak is going up. Which one of the following statements about the change in bread consumption, so bread consumption specifically, is correct? Okay, so the price of steak is going up. What we know is that prior to this happening, the consumer was most likely optimizing. Okay, so we assume consumers are always rational. Their goal is to achieve maximum utility subject to the constraints of how much they have and the prices they face. So we have to take it as a given that just before the price of steak went up, this consumer was optimizing. So this consumer was consuming at a point where the marginal utility of steak over the price of steak was equal to their marginal utility of bread over the price of bread. So that's what the consumer was doing. Now the price of steak went up. What that means is that this denominator, price of S, has gone up. And the effect of that is that the marginal utility of steak divided by the price of steak will now be smaller than it was. And so the marginal utility of bread over the price of bread will now exceed that marginal utility of steak over the price of steak. So the thing that happens for this consumer is that now facing this higher price of steak, they are no longer optimizing their consumption choice. They would need to respond by thinking about where are they going to get the cheapest satisfaction possible now. Okay, so the substitution effect tells us if we could somehow allow you to stay on your original indifference curve, and the way that they talk about this in the textbook is that, let's say we could compensate you with some kind of income. So there was something that could keep you on your same indifference curve. How would this consumer substitute between these two products in order to keep themselves equally satisfied as they were before? According to this new situation, where the marginal utility of bread over the price of bread is greater than the marginal utility of steak over the price of steak, tells us that this consumer would rationally substitute towards bread and away from steak, because bread is now giving them cheaper satisfaction per cost. So the substitution effect for bread will be positive. Okay, so the substitution effect for bread would increase the amount of bread we consume. So A agrees with that. A says substitution effect increases bread consumption. So A is an option. B says both the substitution effect and the income effect increase bread consumption. Okay, so we haven't talked about the income effect yet. So B is still in the game. C says the substitution effect decreases bread consumption. C is automatically out. And then D says both the substitution effect and the income effect decrease bread consumption. D is also out. So now we only have to reason between A and B. So what we're having to figure out is, will the income effect for bread as a result of the price of steak going up be positive or negative? Okay, so how does the price of steak going up affect this consumer's real purchasing power? So if the price of one product goes up, it reduces the consumption possibilities of this consumer. The consumer is now able to choose between fewer combinations of steak and bread. So the price of steak going up shrinks the real purchasing power of this consumer. So how does the consumer respond in terms of the income effect? So the income effect tells us, given how your real purchasing power has been impacted, do you consume more or less normal goods or more or less inferior goods? In this example, I've told you bread is an inferior good. So if real purchasing power goes down because the price of steak has gone up, that means that the consumer would consume more bread as part of the income effect because bread is inferior. So that tells me that both the substitution effect and the income effect increase bread consumption. So the answer to this question is B. Okay, so the effect of a price increase in steak is positive substitution effect for bread and a positive income effect for bread. Does that make sense? Okay, so I'm gonna leave the revision for today here, and I'm gonna pick up tomorrow with the rest of chapter 4 and then the rest on chapter 5. How would a graph for question 14 look? So the question 14 graph I actually did in the revision videos from A1. So those revision videos are still available on EMS Learn. So if you go back there, I did show an example where we have a price increase and one of the products is inferior. I think I did 3 examples of the substitution and income effect for different types of goods in the revision 1. So please still use those revision videos when you prepare for A2. They are still relevant for chapter 3 and 4. Okay. Thank you everybody for joining. I will be back on tomorrow at 2 o'clock, and I will make sure to upload this video later today. One of the lecturers said we are only writing on all the stuff we haven't written on yet. So no, that isn't the case. So for my section of the work, consumer theory, you are writing on chapters 3, 4, and 5. So there is a small overlap with the A1. So please study all of chapter 3, 4, and 5. Okay. So are there no graphs for consumer theory? So you will not be expected to draw the graphs, but I could give you a graph to interpret. Okay, but no, you will not be drawing anything for the A2 for consumer theory. But I'm going to say something now, which maybe some of you will understand. So 271 students are writing on all of the consumer theory work. So if you are currently enrolled for Economics 271, you will be expected to still draw the consumer theory graphs. But if you are writing Economics 217, you are only studying chapters 3, 4, and 5, which means you will not be doing any physical drawing calculations. Everything's going to be true and false in MCQ. Okay, so thanks for asking that question, Ms. Dane, just so that everyone is aware that there is a difference. Which week does chapter 3 start? So chapter 3 starts at the end of week 2. So thanks, Sophia. So everything from week 2, lesson 5 onwards. And tutorials 2, 3, 4, and 5. How many marks is my section? My section of the work is 22 marks of the 100 marks in the test. Okay, so it's 22 marks for my section and 78 marks for the behavioral economics and the producer and firm theory. Okay, great. If you have any other questions, please send me an email. Otherwise, good luck with the studying, and I will see some of you tomorrow.